Alright guys, so what we are doing today, we're going to extend what we were talking about last time. And we're going to look at different ways and different formats that we can still do product quotient rules depending on different pieces that are given to you. Okay, we're looking at graphs, we're looking at the algebra. And let's go ahead and start with the algebra one right here. Alright, so you're given all this information and you're also given this function, f of x. And we're trying to find what is the derivative on f of x, particularly at x is equal to 2. So the at moment today, or for this example, is at x is equal to 2. Okay, so if we're looking for f prime of 2, what do we need to do first? Anyone? What do we need to find first? Just say it out loud. What do we need to find? F prime of x. We need to find f prime of x. Okay? Because otherwise, how else can I plug in my input of 2? Okay? So here we go. Always derive first and then plug in 2. Let me say that one more time. I want you really thinking about that. You need to derive first and then plug in 2. Because if you did it the other way around, what would you get? What would you get? If I plugged in 2 first, and then then you would get 0. Because the derivative of all constants will always be 0. So that's a huge thing. That's why I wanted to say it, because some people make that mistake. Okay? So don't plug in early. So this is my f of x. Okay, so Jordy, what do you see here? What rule of differentiation did we learn last time? Product rule, yeah. So Jordy, what is the product rule? What do I write? Yep, g of x. Perfect. So times h prime of x plus what? Times what? Perfect. So there's our function. Okay, Ryan, what do I do next? Plug in what? Oh, for sure. But our at moment is 2, right? So we're going to plug in 2 everywhere. Okay? So looking at this, like you were about to say, Ryan, what is g of 2? 3. Arjun, what is h prime at 2? 5. And then we're going to add, Braden, what's next? We're going to add what? Negative 1. Perfect. Parentheses are important. This is all equal to my answer, which is f prime of 2. Okay? So anyone, what do I get? 19. So f prime at 2 is 19. Okay? AKA the point 219. Okay? The reason why I keep referring to this, guys, is because we are using this with point-slope formula. Okay? So I want to make sure that you understand what it represents and how we're using it at different locations. Okay? Any questions?
Oh, so that's why the 19 is y?
Yeah, this is the 19 is y. So now this is an x and y graph, and what the confusing part that I just want to make sure that we understand is this right here is an x and a y, but this is representing the slope. Go with me? So that's why I saw the eyes a little bit weird. Okay, so this is an x and y still, right? Input output, but this is giving you the slope.
Because the input is time and the output's velocity, which is...
Well, think about it this way. The input is x, but the output, look, is the derivative, which you're right, is velocity.
So what is m then?
So m would be the slope that's occurring at 2. So maybe I should do it this way. I didn't mean to confuse you if I did. Let me clean this up. Do you agree that the m is 19 at x is equal to 2? Okay. So if I wrote it as a point, position-wise, and I'll only do this, so I mistakenly did that, okay? Let's write it as a point position-wise. It would be 2, but where would I get this y value from? Yeah.
You plug in 2 into f of x.
F of x. You plugged it into the original one. You see what I'm saying? So if you plug 2 into the original one, what's g of 2 times h of 2? Well, it'd be 3 times negative 1. So it'd be negative 3.
So that's the position.
Yeah, this would be the position. And my mistake for changing the way I showed that just now. But yes, xy is the position. Y prime, aka slope, is that 19.
So at that point, the slope is
19, yes. Okay, so with that being said, some people have been asking me this question, and it's a very common mistake that people make, okay? If I wrote this equation, what's the slope?
I don't know yet.
Ah,
The slope of the derivative?
what is the slope?
3x plus 2.
Okay, so Christian said we don't know yet. Omar said 3x plus 2. They're both right. Someone who would mistakenly not know how to read what a slope is from this equation, what mistake would they say? What number would they say the slope is? 3. But it's not 3, right? Because the slope, as we don't know yet, depends upon where we're talking about. If it's at 3, then what would the slope be? 11. If we're talking about what would the slope be at 4, what would be the slope? 14. Go with me? So m is 11 and m is 14. We don't know yet until we have our at moment plugged in. Okay? Alright, so now we did this algebraically. Let's do the same, only we're going to do it graphically. Okay? So the first one I'm trying to look for is h prime at 1. So what is the derivative of h at 1? Well, I don't have an h function. I have an f and I have a g. But I do know that h is built from the multiplication that exists between f of x and g of x. Rovik, what do I do first?
You plug in 1 to f of x and g of x.
Listen, if I plug in 1 right now, what I'm about to find, whoops, just humor me and go with me. What's f of 1? Anybody? F of 1 is 3, right? What is g of 1? Also 3. And h of 1 is 9. Otherwise, what we learned in Algebra 2 or Algebra 1, the position is 1, 9. Do you see it now? But what if I derive this? If I plug in 1 and then derive, what's the derivative of 9? 0. But that's not the order that we do it, okay? Because then they'll all be 0. If we plug in a number first and then derive, they'll all be 0. That's not how it works. We have to derive first, find h prime of x, because that's what we have to find. We have to find what is h prime of x first, right? Because it's waiting for an input. It could be with variables waiting for me to throw in a number. Go with me? Okay. So let's derive h of x. Alec, what's h prime of x equal to? If this is h of x, first of all, let me ask you this. From the shortcut rules that we've learned so far, what are we about to do?
Product rule.
Product rule. Okay, so talk us through this. Talk us through this. Using the product rule, h prime of x will equal what?
f of x
F of x
plus g prime of, or not plus, times g prime of x
times g prime of x
plus
plus
f prime of x
f prime of x
g of x.
times g of x, right? And the only reason why I wrote it in that order is because I was showing you in that order. The first times the derivative of the second plus the second times the derivative of the first. But he's absolutely right. He could have done it his way. Why? Because multiplication does not have order. I could even switch these up if I wanted to, because addition order doesn't matter. Okay, but I'm reinforcing always the way that I've shown you, okay? But yes, there are variations for sure. Danielle, I'm going to now plug in my 1. So then I have f of 1, g. So you can, let me do that just real quick. And if you're struggling, I would suggest this scratch work, just to kind of see pieces. And yes, Danielle, what would f of 1 be?
F of 1 is 3, and g of 1 is also 3?
But this is g
No,
prime.
yeah, I'm saying.
Oh, you're saying way over here. I got you.
That's also 3.
What's g prime at 1?
Do we negative?
Hold on.
It's the slope.
It's
right?
the slope at 1 on the g function.
Yeah, so it would be negative 1?
It would be negative 1. Okay, Danielle, do the next one. What would the slope, what is f prime at 1?
Positive 2.
Positive 2. Nice. Are there any questions from that just happened? Okay. So now, h prime at 1 is going to be what? What's that final answer look like? 3. So h prime at 1, aka the slope is 3 of h of x. Nice. At 1. No, it's subtle, but it's so important because a lot of people don't see those details, okay?
Would it be h prime? Like the slope is 3 of h prime of x, or the slope is 3 of h prime?
That's a good question. He's saying, would it be the slope is 3 of h of x, or would it be the slope is 3 of h prime of x? You tell me. Of h of x. Because the slope of a position function will give me the velocity, or h prime. Because if I said the slope of h prime, I'm actually looking at what? Acceleration. I'm looking at h double prime. Again, the details are, there's huge details in those small little things that we're saying, okay? All right, k of x. Amy, I'm looking for the derivative on k at 6. What do I do first? Yep. And guys, that should be the answer pretty much for the entire first semester. If you don't know what to do, derive something, okay? So here we go. K prime. Amy, what rule of differentiation are we going to use? Quotient. And go ahead, talk us through it.
F of x. Wait. Limit or not?
Not a limit. So quotient order matters, right? Because I'm subtracting. So here we go. Denominator first. So low, right? And keep going in.
F prime of x minus x.
D high minus
F
high
of x times g prime of x.
g prime of x. Low d high minus high d low.
Over g of x squared.
Okay. So a question came up last class, and it was a really good question. It was in the second period this morning. We know ultimately that this is low, bottom square. And someone asked me, Mr. Gomez, since we do this with sine, can we do, if we're going to square g of x, can we put 2 there? What do y'all think? Yes or no, and why?
I'd say no, because it's like, they're not separate values. It's like natural log of x.
I see what you're saying. So you're saying if natural log of x was squared,
It's like all one thing. All one term.
in case you don't know this already, these two are actually equivalent. You can write natural log like that. You really can. I know it's weird. But go ahead.
Well, I G's not like a value. Like,
Well, here's what I'll say. If I wanted the first derivative of f, wouldn't I write f prime? If I wanted the second derivative, I'd write f double prime. If I wanted the third, let's say I wanted the 20th derivative, we're not going to write 20 little apostrophes. We just do this. You with me? So this is why I don't want you to do this, because this could be the second derivative of g of x.
and the second derivative isn't
It's
velocity, that's acceleration, right?
yeah, and it's not the same as g of x squared.
What even would be the 20th derivative?
Oh, crazy stuff. All right, so let's keep going.
It's gonna be a bonus question.
Yeah.
You put brackets, like where the g of x is, or can you put parentheses?
Yeah, you can put parentheses. The only reason why I put brackets is because too many parentheses, sometimes it's hard to see where you're at, you know what I mean? So it's just a visual thing. Alright, here we go. 6 is now going to be placed here, 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 and here. Anyone, what's g of 6? 1, 2, 3, 4, 5, 6. Yep. What is f prime? Let's go with Nate. What is f prime at 6?
Sorry.
That's okay.
Get in the cell.
So it's the slope of f at 6.
-1/2.
Negative 1/2. Okay. Matthew, what is f of 6 going to give us? Four. Nice. 4. And what is anyone? G prime at 6? Negative 2. And it's all over g of 6 squared. So what's g of 6? So it'd be over 4. So k prime at 6 is all of that. Notice we have a negative 1, right? Negative 1 plus 8. So what's my final answer? 7/4. K prime at 6 is 7/4. Otherwise, m equals 7/4 of k of x at x is equal to 6. Cool? All right. So now, let's look at this one. So I have this rational function, and it says find all the points where the graph of f has a horizontal tangent. So this is important. What does that mean? Go ahead, anyone. Slope is 0. So if the slope is 0, and I'm using calculus notation, I could say f prime of x is 0. Okay? And we're going to see where does this occur. It's like we're working backwards. So let's derive. Arjun, what rule of differentiation am I using? Quotient rule, yeah. So help us out. Go ahead.
X squared.
Low. No worries. So low d high, the derivative of the numerator. What's the derivative of the numerator? 3. So low d high minus, keep going.
Okay. High. 3x minus 2.
Yep, 3x minus 2.
2.
Not 2, 2x. Okay, so 2x. All over what, guys? X to the 4th. Now listen. X to the 4th happened because I squared the denominator. You go with me? Now please, please, please don't forget. How did we do that? What did we do with those 2's to get a 4th? We multiplied. If you're about to say add, please write this in your notes. x squared raised to the third power is x to the sixth. But x squared times x cubed is x to the fifth. Know the difference, okay? For sure. Because we're going to do a lot of that. Okay. We want the derivative to equal 0. That means this whole derivative function that we just got, we want it to equal 0. Oops. And on a fraction, something will equal 0 when what equals 0? The numerator, not the denominator. So if there's a number that is not 0 in the denominator, and there is a 0 here, what does all that yield? 0. But if there's a 0 in the denominator, undefined. Okay? Those are huge concepts that we're going to talk about a lot this year, okay? All right. So, what do y'all suggest? What do I do right now? Go ahead, Omar.
Multiply by x to the fourth on both sides.
Multiply by x to the fourth on both sides? Okay.
So then you do it.
Okay, so be careful with that, okay? So a lot of people want to do that, and there's nothing wrong with that suggestion because people thought that from algebra 2. But here's the thing. If I simplify this, I have 3x squared minus 6x squared, what? Plus, the most common mistake, right?
Oh, you distributed that first.
Distribute it. So it would give me plus what?
4x.
4x, right? So 4x all over x to the fourth. Now watch me. Real quick. 3x squared minus 6x squared is going to give me a negative 3x squared. And I'm going to show you why we don't want to necessarily just multiply it out, okay? Because what you're going to do is you're going to take out half of your answers if you do that, okay? But you'll see why. 3 letters right now that I'm thinking about, what are they? GCF. GCF, the numerator. What could I pull out? X. So if I pull out an x, I'm left with negative 3x plus 4 and x to the fourth. Go with me? Here we go. Y'all said it up here. You said it. If the numerator is 0, then this should equal 0. So what are the zeros of my numerator? Well, the first one is x equals 0. And this other one, if I set it equal to 0 and solve, is going to be what? A positive 4/3, right?
Yeah, because it equals 0.
Yep. So here's the thing. Are both of these answers? No, they're not both answers because the bottom will cancel as a removable discontinuity. And you'll have x cubed left on the bottom. You with me? But you wouldn't see that if you multiplied both sides per se. Y'all with me? So just keep that in mind. Okay? So this removable discontinuity zeroes out. So 4/3 is the only one that I'm looking at. Okay, here we go. So 4/3 is the x value. But I'm not done because I was asked for the point. So I have to plug it into the original position function to get that point. It's like you keep going back and forth between f prime and f of x. Or all 3 levels. You keep going back and forth to grab pieces that you need. So let's plug in 4/3 right here and right here. So 4/3 times 3? 4. Minus 2? 2. And then 4/3 squared? 16/9. And 12 divided by 2 divided by 16/9 is the same as 2 times what? 9 over 16. You know this 2 is over and understood 1, and you can reduce early. What's my final answer? 9/8 will be the y value. You with me? Because this other one, guys, 0, that canceled out could be an undefined. It could be a vertical tangent. It could be a removable discontinuity. You see what I'm saying? You see what I'm saying, guys? It could be a cusp. I might be going a little bit too far with that, but can y'all remember what this was? Was this f of x or f prime of x? F prime. And if this 0 doesn't work, because it would make this undefined as a slope, you see where we just went? That's where I want to take you. Because an undefined slope can look like what? Vertical tangent. Yep. A removable discontinuity. What else can an undefined slope look like? A cusp. There's one more, guys. You can take it home. An endpoint. Cool? Alright, good stuff. Good stuff. Alright, so now what I want to do, chain rule, we're actually going to wait on chain rule, so you don't have to worry about any chain rule, and I'm going to take it off from the current web assignment, okay? Someone from second period, shouts out to Athy, he learned it on his own. You don't have to do that, guys. I'm going to take those questions off from web assignment. It'll be next unit. But what we are going to do is we're going to go to one more representation of the definition of the derivative, which we put in the unit that we're in now. And then when we finish, I will answer any questions that you have from homework. We can record them as well. Or any questions you have in general before your quiz. Alright, here we go, right here. The quiz will be the last 30 minutes of class. Okay? Definition of the derivative. All of this gives me what? F prime of x. That's the goal. Okay? And I might try to trick you sometimes, because looking at this that I'm going to box in orange, to me, what do you think the most important number up there, or letter, or whatever it is, that I could try to trick you on a quiz question or on a test question? Close. Not H, but 0. If I try to give you this, like an example problem, but I put infinity, you can't do what I'm about to show you. You would treat it as an infinite limit. You with me? Okay, here we go. Here's the thing. If this gives me f prime of x, which is the derivative of what? F of x. And in the original problem, f of x is right there. The shortcut is f of x is what in this first example right here? What's f of x? 2x cubed. And if doing all this work, right, is going to give me f prime, but I know f of x, I could just do a shortcut right now, because I now know derivatives, and what would the answer be? 6x squared done. Okay, listen. If I tell you, so on your quiz today, it says use the definition of the derivative, it's the long way, okay? This unit will be the only time all year that you will have to show it the long way, okay? After that, you will never have to show that ever again, but I want to make sure that you know how to use the definition of the derivative and the alternative form. Okay, remember the alternative form? F of x minus f of c over what? X minus c as x approaches what? C. As x approaches c. Because if x approaches 0, then the bottom would be negative c. You see what I'm saying? It would never approach 0. X has to approach c. You want this to try to become c to make the bottom approach 0. Yeah?
Can there be questions that tell us we have to use the alternative form?
Yes. There'll be questions on the test that say using alternative form. There'll be questions on the test saying using the definition of the derivative, long form. But if it doesn't say that, you guys can use shortcuts all you want.
Alternative forms that one.
Yeah, this is alternative form right here. We ready? We're good? Yeah.
So on the quiz, if you say like use definition of the derivative or use alternative form, will it have the formula there?
It won't. You have to memorize this form. These formulas you have to know. Okay.
Alternative formula again, please.
Just on the test. I'll give you that heads up. The alternative form is not on the quiz, but the definition of the derivative is. Okay. All right. Here we go. Here we go. This one's a little bit different. Think about it. What's f of x? Oh, first of all, can I do the shortcut that I just showed you? Yes. What's f of x? Is it negative or positive? Positive. Now look, you don't know chain rule yet. You don't. And because you don't know chain rule, I can't give you 5x right now. I can't. So I'm just going to change this up just a little bit. And I'm going to make those 5's go away. And I'm just going to call it cosine of x. Because you don't know chain rule yet. Okay? We'll learn that next unit. So what's my answer? Negative sine of x. Okay, the last one. Some people will get it, some people don't. On the first try. No worries. Just keep trying and keep looking at it. Can I use the shortcut? Yeah. Here we go. What's f of x? It can't be 1/2.
Sine of pi over 6.
Can't be sine of pi over 6 because then they would all be what? 0. When you take the derivatives of constants, you'll always get 0. There we go. So this one's going to be sine of x.
How did you see that?
Here we go. This is like sine of x plus h minus sine of x all over h as h is approaching 0. But then you're looking at this, you're like, wait, what? How is this that? Because my at moment is when x is pi over 6. This almost feels like alternative form. Because there's a constant right here. And on the alternative form, you always see that constant there as f of c. But why isn't it not the alternative form? Because I don't have x minus c in the denominator. There's not two numbers. You know what I mean? A variable subtracting that constant. You all see it? So sine of x is f of x. So what do I do next? Take the derivative. What is it? Cosine of x. What do I do next? Plug in pi over 6. That's the difference, guys. When you have a constant here, that means you're going to not only establish what the function is, derive it, but at the very, very end, this is actually looking for. So you're used to this saying f prime of x. But when you have a constant right here, it's not f prime of x. It's f prime at what? Pi over 6. Questions? And then you just solve it. Yeah, so pi over 6. What's the cosine at pi over 6? Root 3 over 2. That's your answer. But not 0. It would be way too easy for that, right? Okay? Questions? Alright. So now I will answer questions that you have from homework and record them on another video.